Uh, AC Verma, chapter thermodynamics, question number 22, page number 64. An adiabatic vessel of total volume P is divided into two equal parts by a conducting separator. The separator is fixed in this position. The part on the left contains 1 mole of an ideal gas, and it follows the equation internal energy U is equal to 1.5 nRT, and the part on the right contains 2 moles of the same gas. Initially, Initially the pressure on each side is P. The system is left for sufficient time so that a steady state is reached. Find A, the work done by the gas in the left part during the process. B, the temperature on the two sides in the beginning. C, the final common temperature reached by the gases. And D, the heat given to the gas in the right part. And E, the increase in the internal energy of the gas in the left part. So let us solve this. This is the container. This is an adiabatic container. That means it is not losing any heat. And this is exactly divided into two parts, and the container have volume P, so it has got a volume P by 2. Even this got P by 2. This separator is a conducting one, so heat can travel through this, and the pressure of the first part is P, even of the second part is P, and temperature has not been given. uh, its number of moles is 1 and its number of moles is 2. So it is clear that as the gas is ideal, so it will follow PV is equal to nRT, right? Look, both the parts have same P, same B, but the number of moles are different. That's why temperatures will be different. So let me consider its temperature is T1 and its temperature is T2, right? And the gases follow the internal energy equation 1.5 nRT. These are the given datas. Now I have to solve the sums. In the first question, it has been asked the work done by the gas in the left part during the process. This is the left part. What is the work done by the gas over here? Look, the separator is fixed, so there is no change in the position of the separator, but the work done has the basic definition PdV, so there is no change in volume. So the answer for A part will be 0. No change in volume, so no work done by the left part. If they ask what is the work done by the right part, then again we will say no work done by the right part because the separator is not changing. In B, they have asked the temperature on the two sides in the beginning. Temperature on the two sides in the beginning. So P B by 2 N1 R T1. This is the equation. They have given us N is equal to 1. So the T1 will come what? PV by 2R. This is the temperature, initial temperature of the left part. Similarly, for the second part, that is this part, N2 R T2, right? So PV by 2 2R T2. So initial temperature of the left part is PV by 2R, and the initial temperature of the right part is PV by 4R. So it's clear the temperature of the left part is more than that of the right part. So the heat will flow from this side to this side. It has more heat, so heat will flow from this side to this side. Okay. Heat doesn't depend on the number of moles. Heat will flow depending on the temperature. not on the total heat. Okay, it doesn't depend on the total heat flow does not depend on the total heat, it depends on the temperature. So as T1 is greater than T2, so heat will flow from this side to this side. Okay, so these are the answers for B. They are asking the final common temperature reached by the gases, final common temperature, right? So I have to answer for C now. Look, it is losing internal energy and it is gaining that. So from that concept I will get the final temperature. What is the heat loss by the left side? 1.5 into N1, 1.5 into N1 into T1 minus T. Let me say the final temperature is T. It is the heat loss by this, and heat gain by the second part, that is this part, is 1.5 into N2 into T minus T2, because final temperature is always in between the maximum temperature and the minimum temperature. So why I'm telling the heat loss? Heat loss should be dq, but why I'm telling du? Because dw is 0. I know that dq shown du plus dw, but as dw is 0, so heat loss equal to this. So by condition they are equal, so 1.5 . So now put the values of T1 and T2. T1 was PV by 2R and T2 was PV by 4R. So this is the addition sign, okay? So it will become PV by 2R by 3. So it will be PV by 3R. PV by 3R. It is the answer for question C, the final common temperature. In D, they have asked that the heat given to the gas in the right part. What is the heat given to the right part? Obviously, is given by this. It is equal to its change in internal energy, du1. It is 1.5 into n1 into t1 minus t, right? T1 was PV by 2R, and now I just have got T, it is PV by 3R. So 1.5 PV by 6R. Oh, I have lost, I have not written any R in the whole procedure, okay? So here there will be a R, there will be a R 1.5 and 1R. Though the answer of C part will not change, because here will be a R and even here will be a R, so they will get cancelled. So answer for C part will remain unaffected. But here for the D part, I have to write the R, right? So into R, so into another R. So the answer will be what? PB by 4. PB by 4. This is the heat loss or the heat given to the right part. Heat loss by the left part is equal to the heat gain by the right part. And in E question they have asked us, okay, what is the increase in internal energy of the gas in the left part? Look, the left part has lost heat. So its internal energy is not increased, rather decreased. Okay, how much internal energy it has lost? Its value is PV by 4. So if they are asking us what is the increase, increase is a negative increase because it has decreases. So the answer for E part is equal to the loss of internal energy. That is, increase in internal energy is minus PV by 4. This amount of energy is given by the left part to the right part. So when somebody keeps, how its energy can increase? It is actually decreased, and decrease means negative increase. That's why it is minus PV by 4.